Did you know that the phone in your pocket, the jewelry on your finger, and the fuel in your car all started their journey miles beneath your feet? We walk on a crust of rock, but just below us lies a hidden vault of unimaginable wealth. Gold, silver, oil, gas, coal, and even the steel in our skyscrapers, they are all here. But where exactly? Are they floating in molten lava? Are they buried in ancient mud? And how on earth do we actually get them out? Today, we are going deep, deeper than any human has ever drilled, to uncover the secrets of Earth's natural resources. Let's dig in. To find the treasure, we must know the map. The Earth is like a giant layered cake. At the very top is the crust, the thin, cool skin we live on. It's only about 30 kilometers deep on average. That sounds deep, but compared to the Earth's center, it's thinner than the skin on an apple. Below the crust is the mantle, a thick layer of dense, semi-solid rock that moves very slowly like thick honey. Beneath that is the outer core, made of liquid iron and nickel that swirls around, creating our magnetic field. And finally, the inner core, a solid ball of superheated iron, hotter than the surface of the sun. But interestingly, we don't dig down to the core. Most of the resources we use are found in the crust and the very top of the mantle. Let's talk about the fuels that power our world: oil, gas, and coal. These are called fossil fuels for a reason. Wait for it, because they are literally made from dead animals and plants. Hundreds of millions of years ago, tiny plants and animals called plankton lived in the oceans. When they died, they sank to the bottom. Normally, they would rot, but down there was no oxygen. Over millions of years, they were buried under layers of mud and sand. The heat from the earth and the pressure from the heavy rock above cooked them. This chemical process turned the gooey mud into a thick, black liquid, oil, and a lighter gas, natural gas. What about coal? That comes from ancient forests and swamps. When giant trees died, they fell into the water and were buried before they could decay. Over time, immense pressure squeezed out all the water and air, leaving behind pure carbon. That's coal. So where do we find them? We find them trapped in porous rocks like sponges, deep underground, often under the seabed. To get them out, we don't just dig a hole. We drill deep into the earth using massive rigs. When a drill hits the pocket, the pressure forces the oil and gas up to the surface. But it's not easy. We often have to pump water or steam down to push the oil out. Now let's move to the shiny stuff: gold, silver, and copper. Where do these metals come from? Did you know they are actually born in the stars? When massive stars explode, supernovas, they create heavy elements including gold and silver. These elements were part of the dust cloud that formed our planet billions of years ago. So they were here from the start, but they were scattered everywhere. So how did they form into veins that we can mine? The answer is water and volcanoes. Deep down, there are superheated, mineral-rich fluids called magmatic fluids trapped in the Earth's crust. As the Earth's tectonic plates move and collide, they create cracks. These hot fluids travel up through the cracks. As they rise, they cool down. When they cool, the minerals inside them, gold, silver, and copper, crystallize and solidify into solid veins. Think of it like dissolving sugar in hot water and then letting it cool. The sugar forms a solid crust at the bottom. That is exactly how a gold vein is formed. So where are they? Most are found deep within the bedrock. But sometimes they get pushed up toward the surface by volcanoes. Lava can carry these metals up, or earthquakes can shatter the rock, exposing the veins. We extract these by hard rock mining. We blast tunnels into the mountain, crush the rock into powder, and use chemicals or gravity to separate the heavy metals from the dust. What about the structural materials? Iron and limestone. These are different. Iron is not usually found as a pure metal, but as an ore, a rock mixed with iron oxide, rust. Most of the world's iron comes from a rock called banded iron formation. Where did it come from? Billions of years ago, the oceans were full of dissolved iron. As microscopic bacteria started producing oxygen, that oxygen reacted with the iron and caused it to turn to rust and sink to the ocean floor. It settled in layers year after year for 1 billion years. That huge stack of rusted rock is what we now mine for steel. We find it in huge open pit mines on every continent. And then there's limestone. This is a biological rock. It's made of the shells and skeletons of tiny marine animals like corals and clams. When they die, their shells fall to the bottom. Over millions of years, pressure cements them into a solid rock. So when you walk on a limestone cliff, you are literally walking on a graveyard of ancient sea creatures. We use limestone to make cement and concrete, the foundation of our cities. We extract it by drilling and blasting the rock face, then crushing it down. So how do these deep resources get close enough for us to reach? It's all thanks to the Earth's tectonic plates. These giant slabs of rock are constantly moving, maybe a few centimeters a year. When two plates crash into each other, they build mountains. As the mountains rise, they push the deep mineral veins closer to the surface, sometimes revealing them completely. If one plate dives under another, we call this subduction. It carries water and rock deep into the mantle. The heat melts the rock, creating magma. That magma rises and erupts as a volcano. When it erupts, it brings with it huge amounts of copper and gold from the depths, depositing them on the surface. Earthquakes also play a role. They crack the crust, opening channels for hot, mineral-rich water to flow up and deposit new metal. Finding it is one thing, getting it out is another. Humans have become masters at extraction, and we use three main methods. First, surface mining. If the resource is close to the surface, we dig a giant bowl called an open-pit mine. These are huge, visible from space. We drill holes, put explosives in them, blow the rock apart, and haul it away. Second, underground mining. If the vein goes deep, we dig tunnels. We create mine shafts that go straight down and horizontal tunnels that follow the gold or silver veins. It's like an ant farm underground. We use massive machines to drill and blast the rock, then bring it up in elevators. Third, leaching and processing. Once the rock is out, it's crushed into dust. For gold, we use cyanide or mercury to dissolve the gold out of the rock. For copper, we use acid. For iron, we use heat. We smelt the ore in massive furnaces at over 2,000 degrees Fahrenheit to melt the metal away from the rock. It's a dangerous, expensive, and incredible process that requires thousands of people working 24/7. So the next time you pour gas into your car, hold a gold necklace, or walk on a concrete sidewalk, remember the journey. That gold was forged in a supernova, carried by magma and compressed by earthquakes. That oil was once a microscopic algae living in an ancient ocean. And that concrete is made from the shells of dead sea creatures. The Earth is not just a rock. It is a living, dynamic machine that has been recycling and creating resources for 4.5 billion years. But here is the important question. We are extracting these resources faster than the Earth can create them. It takes 500 million years to create a coal deposit, but we burn it in seconds. As we dig deeper and deeper, we must learn to respect the vault. Because once the treasure is gone, it takes the Earth a very, very long time to make more. Thanks for coming on this journey with us. Don't forget to subscribe and hit the bell to go on more adventures into the unknown.